Hi guys, and welcome to lesson 6 of our coast unit. Today we're going to be looking at something called the process of deposition. As always, your activity will be to watch this video from start to finish and pause it at appropriate moments if I ask any questions. At the end of the video, there will be 3 review questions which I would like to answer and upload onto Satchel 1. So, we've spent a fair amount of time so far looking at the processes which occur along the coastline. We started off by looking at erosion, which was basically the process by which rock was being worn away. We looked at things like weathering, and we looked at marine erosion as well. Then in our previous lesson, we looked at this concept of transportation. So once that material has been eroded, it is then moved elsewhere. And we looked at, in particular, the process of longshore drift. Now, longshore drift was where material is moved in the direction of the prevailing wind to somewhere else. And then today, we're going to look at the third process, which is deposition. And essentially, the little man there is saying, I cannot carry them any further, so I drop them. And so deposition is basically where the material that has been transported stops being transported, it is dropped off there. So kind of think of it like the end of the train journey for those pieces of sediment. And so if we recall, transportation was the movement of material in the sea and along the coast. And when materials are eroded, they are then transported along the coast. And we did look in some detail at this diagram. And this diagram is really important to us understanding the concept of deposition, because it basically explains why transportation doesn't happen forever. But if you recall, a sediment, let's say it starts on the left side of the image here, is moved via swash and backwash at the angles shown here in the direction of the prevailing wind. So the prevailing wind is the direction in which the wind flows in the most. And so if the wind is flowing in this northeast direction the most, that is the direction of the prevailing wind. If you recall, the backwash always comes back at a 90-degree angle, and that is due to gravity. And so the idea here is that, again, it would mean that a piece of sediment, maybe a small rock, would move along that shoreline over time. Now, it's not a particularly fast process, it doesn't happen overnight, but over a long period of time, that sediment would end up moving in that direction. However, as shown there. And so, if we're going to really bring this process together then, we've seen erosion, which is that hydraulic action, attrition, solution, and abrasion. We've looked at the weathering, which is the physical, biological, and chemical. They all cause cliffs and rocks to break down into material, shingle, and pebble. Over time, they are then transported via transportation and longshore drift until finally we are now at the deposition stage. And the reason why I keep going back to these so much is because it's really important for you guys to understand that this is all part of the same system. So these 3 things are happening in tandem. They are happening across coastlines around the entire world, not just the UK. And if you understand where that sediment has come from, it makes deposition under the landforms seem a little bit clearer as well. So, deposition, what is it? Well, deposition is when the sea loses energy. And when it loses that energy, it drops the sand, rock, and pebbles it has been carrying. And this is caused deposition. Okay, so when the sea loses energy, it drops the sand, rock, and pebbles it's been carrying, and this causes deposition. And deposition only ever happens when the swash is stronger than the backwash. And we know from our first lesson of this unit that is therefore associated with our constructive waves. A constructive wave builds up or constructs materials as opposed to a destructive wave which destroys them. So whenever we have deposition, it has to be a low energy wave, and it has to be a wave which has a very large swash, very strong swash rather, and a very weak backwash. Now, if we tie back into this definition of deposition, it says here that the sea loses energy and drops the sand or the rock particles. What I would like you to do here is I would like you just to pause this video in a second, and if you have a piece of pen or paper next to you, or you have a Word document, I would like you just to jot down maybe one or two ideas. Well, why might the sea lose energy? So think about what the sea is, think about what waves are, and think about what might cause the sea or the area to lose their energy. Once you've had a go at that and had to think about it, unpause the video and carry on with the rest of it. Okay, so on that point then, we're going to get onto that question in a second, but basically let's kind of recap that then. Weak backwash, strong swash, the beach is built up. And so in terms of our reasonings then, there are four main reasons why that sea loses its energy and therefore deposition occurs. Firstly, waves enter an area of shallow water. So when a wave enters an area of shallow water, it loses energy because as you get into shallower water, there is less and less space for that wave. Therefore, it starts to crest and therefore it slows down. And as that wave slows down, it isn't able to push the material as much. The second reason, and perhaps most importantly, is when the waves enter a sheltered area like a cove or a bay. So if the waves enter like a bay which is protected on both sides by a headland, it will therefore not be particularly windy. As we already know, the strength of a wave is very much determined by how strong the wind is. So if we are in an area that is protected and shielded by the wind, the wave will lose energy. If it loses energy, it might have to drop whatever it's carrying because it can only carry large pieces of pebbles if it's got that momentum behind it. If the wind is being blocked off by a cove or a bay, then quite frankly, it won't be able to continue with that, and therefore it drops it, and therefore deposition eventually occurs. And our second two reason is basically a very similar one indeed. So not only is it to do with the fact they enter into bays, there are also days in which the wind or there is less wind occurring. And so if, for example, the prevailing wind is blowing in one direction, once it gets to a certain part of the coastline, it may not receive the wind anymore, or it may not be as particularly windy as it was. So if there is little wind, then they're less likely to carry on that material, and therefore they're likely to deposit it. And this final point here is there's a good supply of material. Now this is a bit of a curveball really, because it's not explaining why deposition happens, but what it's saying is that for this process to happen, there has to be a good supply of material. If we go back to this diagram here, and we're looking at this final stage here, if there is very little erosion, so very little weathering, very little of this here, there will be very little transportation and therefore very little deposition. So for deposition to occur, there has to be a large amount of these erosional processes, and that's a really important concept to understanding what's going on the coastline here. And so we take it back then, eventually, if, for example, we've got very little wind, it's very shallow, and we've got lots of material, we end up with like beaches being formed. And you can see on this picture here, this is an example of a headland, this is a bay. The bay will be sheltered from this wind here, and therefore these waves, as you can see, look really, really small. They've got very little energy. If they are low energy, that means they will be called a constructive wave, which basically means they have a very strong swash and the beach would likely to be built up. And that's why when we see our headlands and bays, the bays tend to have small beaches in them because the headlands kind of act as a natural barrier to the elements. So instead of there being destructive waves, we tend to always have constructive waves in a bay, and therefore we have our beaches forming. And so this leads to lots of new landforms being created. We're going to look at bars and spits in our next lesson, but in the same way that erosion led to landforms, deposition does the exact same thing. Okay, so just to recap the lesson, we've looked at the idea that deposition is the final transport process on the coast after erosion and transportation. It's where the materials or the sea loses energy and deposits or drops the sand, rock, and pebbles that it's been carrying. We then looked at these 4 factors that are likely to cause deposition to occur. And you can flick back through this video and have a look at them again as you please. To finish off then, guys, what I'd like to do is, there are 3 review questions, and they are as follows. Explain what is meant by the term deposition. Outline the factors which make deposition likely to occur, and explain how coastal processes impact cliff material, where do they end up and how. So the first question is quite straightforward. The second one is you are talking about these things here. And the final one is basically saying, how does material end up from a cliff onto that beach there? So you really, to do that last question, you basically want to talk us through this diagram. So you want to explain the process of erosion, transportation, and deposition to answer that question. If you are a bit unsure about how to answer that, as always, there will be a live Zoom support, or you can simply ask this question on Satchel One. Any problems, let me know. Otherwise, please have a crack at those 3 questions and upload your answers onto the platform.